All right, C++, we're continuing on page 300 in chapter 7. We're going to be dissecting the next two programs that are displayed in your textbook. The class gradebook, using an array to store our grades. So we are going to be creating a new class object. It's going to be a gradebook class object. So we will make its definition in a gradebook.h header file. Now the output is shown to us on page 300. So let's just look at the output and see what our expectations are. We want to welcome the instructor to the gradebook for the course CS101, Introduction to C++ Programming. The grades are, and we have student 1 through 10, and we have 10 grades assigned. We want to calculate the class average. Looks like a double with 2 places following the decimal point. We want to know the lowest grade that was earned and the highest grade that was earned on this particular assignment. And then we're going to produce a grade distribution chart, which we've done before. So we know that within each range, 0 through 9, 10 through 19, 60 through 69, there was only 1 score received. 70 through 79, only 2. And you can briefly look back at your scores that were posted and determine that that's correct. So let's go on to page 300, where we introduce the gradebook.h header file defining the class object gradebook. Now we have our include files. Of course, we need to include an array because we're going to use a class array template to store the 10 student earned grades. Our class definition begins with the class gradebook. Remember, it must start with an uppercase as a class name. And we're declaring this to be public, and the public continues through the private section. We have a constant number of students who took the test. So no matter how many gradebook objects we instantiate, a gradebook object is going to be maintaining 10 grades. Now it's declared as static, so it will be known to all gradebook objects, but it's going to be a constant size students, and it's initialized to a size of 10. So the students is a constant size of 10. We have our constructor that initializes a course name and a grades array for each gradebook object. So we're going to create a new object of class gradebook. It's going to have a constant string reference, and we're going to send a name, and that name is going to be referenced by the variable name. So whatever string is passed to name, it's going to be referencing that variable in that class object. We're also going to expect that a constant standard array template class of type int, where students is already a known size of 10, is going to be referenced by our variable grades array. So whatever array is sent to or passed to gradebook as a constructor that will be referencing that gradebook as a constant, so we will not be able to change the grades in the gradebook but we will be able to get a copy of the grades in the grade book, as grades array will reference that copy. And then locally, we have a course name variable, and it's going to be initialized with the braces to name whatever string was passed to this gradebook constructor. And grades will be initialized to grades array, so that's whatever array reference was sent to this gradebook constructor. We have several functions as member functions. So let's see if we can take a visual look at designing the UML. So we're back to designing a gradebook class object. We're going to define its data members and its data function members. The data members for each gradebook object, remember each gradebook object maintains its own data members, will have a string by the name of course name, and course name, it's the course name for this gradebook object. And it will have a variable of grades, which is of array template class. It's going to be storing integers, and it's going to be of a size students, where in the driver program and in the constructor, students is a static constant, which means it's known to all class objects, but it's going to be a constant, so it cannot be changed. So all class objects of type gradebook will have a class array integer size of 10. And remember, that's subscript 0 through 9 for 10 elements. So array is a class template. It's going to be storing integers for a class size of students, and it'll be storing our student grades. So each gradebook class object can store grades for this test, this assignment, the next project, scores earned by 10 students. As we continue with building the visual for our gradebook class object, we have our constructor. We're naming this object gradebook. It's going to have a name variable, which is referencing a string passed to it. It's going to have a grade array, which is referencing an array of type integer of type students that is sent to it, where students is declared to be static constant, known to all class objects, but a constant. So all class gradebook objects will have the same gradebook size for the array, maintaining the number of student grades for that particular assignment. We have a get course name, which is a string reference. We have a set course name. A get course name returns a string reference. Set course name expects a name as a string reference. We're familiar with the get and set. We have a void display message method or function. We have a void process grades function. We have a void output grades member function. We have a get average, which will return a double to the calling environment. Get the minimum, which will return an integer to the calling environment. Get maximum, that's going to be a member function that's going to return an integer to the calling environment. And then void output bar chart, which will display the output bar chart frequency for report. So gradebook is a class object. When we instantiate or declare a new gradebook class object, that gradebook class object will know its own course name, and it will know its own grades array values. It will have access to all the member functions within the gradebook.h definition, which is your gradebook.h header file. So our constructor initializes a new gradebook object with a past string reference and a past array reference. We will name the local variable course name with the past string name reference, and grades will be initialized to the past grades array reference to the array template containing integer values and a student's size. Next, the header continues to define the member functions. We have void set course name. Well, we're going to want to set the course name to the name of the course as a string reference. So course name will be equal to the name string reference passed to this method. Function get course name is going to return a constant string reference. It's going to return course name. Void display message is going to display a message, welcome to the gradebook for, and then we're going to get the course name. And of course, the course name will be the current course name of this gradebook class object. We have a void process grades. Every class object will know how to process its own grades. As a member function, process grades calls output grades. So we'll move to the output grades method. Output grades does not return anything. It's not expecting anything to be passed to it. So we process and output the grades are, and a couple of new lines. And then we are in a for statement for student size. We're set student to 0. Student is less than grades.size, which is set to 10. We'll increment students as we iterate through the loop. We're going to output student, set some spacing, and then student plus 1. Now remember, student is a subscript 0 through 9. So our subscripts, when we want to output, we'll want student 1. We want to use 0 plus 1 for student 1, actually. And so for student 1, we want grades sub 0, because in the grades array, the first student score is stored in grades sub 0. So the first student, 0 plus 1, the first student's grade is stored in grades sub 0. Remember, we have a grades size of 10, that's subscripts 0 through 9. Next time through, student is 1. It's less than grades.size, so we'll output student, and then we're going to output 1 plus 1 for student 2, and student 2's grades are stored in the grades array subscript 1. Remember that off by 1 scenario. And so on. So we're just iterating through the grades array and outputting student 1 and student 1's grades from the grades array. Student 2's and student 2's grade from the grades subscript array. And when we're done, we're going back to output grades was called. We're going to continue to process, set some precision in 2 places following the decimal point. Then the class average is, we're labeling and we're going to get the average. So we're calling get average member function. And the get average member function returns a double value. It doesn't expect any value to be passed to it. We have a local integer set to local integer by the name of total initialized to 0. So for int grade colon grades, we're using the range-based for statement, where our range variable is grade, and we're using the grades array subscript 0 through the end of the array subscript 9. So we're going to iterate through grade sub 0, grade sub 1, grade sub 2 until we reach the last element in the grades array. And along the way, we are totaling whatever total was equal to. We're going to add that to the next grade. So the next grade will be added to total's current value. The next grade will be added to total current value. So when we are finished with this range-based for statement, we will have total, which is the sum of all 10 grades from the student grades array. Next, we return static constant double, whatever total's value is. It will be returned now as a total divided by grade size. So our total value for the number of grades result, the total of the sum of all student grades divided by 10. We're going to return that as a static cast. We're going to make sure it goes to a double because we're returning a double. And we'll return that to the calling environment where we called get average. That result with a precision of 2 places following a decimal point will be output with a new line. Then call the get minimum and get maximum functions. So we're going to output the lowest grade is, get the minimum. We'll call the minimum function. We've seen this before. It will return an integer. It's return a single value. Int is a local variable named low grade. It's initialized to 100. So we're assuming that the lowest grade is 100. Now we iterate through the loop with a range-based for statement. We'll be referencing every element of the grades array and assigning it to grade. If grade is less than low grade, then the low grade would be equal to grade. So if the grade in the grade sub-0 compartment is lower than our low grade of 100, low grade will be assigned that grade's value. We iterate through the for, comparing each subscript's value to low grade and making the low grade always equal to the lowest grade in the grades array. So when we're done iterating with the range-based for statement, we will return the low grade as an integer to the calling environment. So we'll return the minimum. It will be output. We'll continue. The highest grade is get maximum. We're calling the get maximum method. All objects know their own methods. Get maximum is going to return an integer value, so we're going to make use of a local high grade variable of type int and initialize it to 0. So we're assuming that the lowest grade would be a 0, and high grade would be greater than that value. So high grade is now initialized to what we would expect would be the lowest grade possible. We're going to compare using a for range again. Every subscript in the grades array will be assigned to grade as we iterate through this loop. And if grade now is greater than high grade, which is 0, we'll assign high grade to that value. Iterate to the next grade's subscript and assign it to grade and compare. Is it higher than the current value of high grade? If so, high grade is equal to grade. Otherwise, we just continue to iterate and compare and make that assignment to high grade. When done iterating through the grades array using the range-based for statement, will return the found high grade as an integer to the calling environment. So get maximum returns as an integer the highest grade, so we print out the value returned from get maximum and a new line, and we call output bar chart. All objects know their own methods, so our object can make use of the output bar chart. It returns nothing, it expects nothing to be passed to it. We're going to output grade distribution as a title to our report. We're going to use our frequency size of 11 to maintain the count for the frequency of the number of grades within the range 0 to 9, 10 to 19, 20 to 29, and so on, and print the number of correct stars representing the number of scores that occur within that range. And when we're done, we print a new line. Just a reminder that for any of our C out or C in, our standard end out line, you do need to include the directive std : because we are in a header file, and that's required. Okay, let's take a look at our driver program, which is our figure 07-13-14 CPP file. The driver program creates gradebook objects using an array of grades. So we are including the array template class, and we're including our own gradebook.h header file, which is our gradebook definition for the gradebook object. Int main begin end. We have a constant array int gradebook : students and grades. Grades is the name of our array. It's going to be a constant array template of type int, where it's a gradebook object and a size of students. The : says that we are using, it's the operator that says we're using the student's value as a constant from the header constructor definition. And the header constructor initializes students to a static constant size of 10. So students is known to all class objects of gradebook, but it's going to be a constant size. So for any gradebook instantiation, we are only allowing 10 student grades to be populated to the grades array. That keeps all arrays the same size for all gradebook objects. And we're going to initialize our grades array to 10 grades: 87, 68, 94, 100, 83, 78, 85, 91, 76, and 87. And if you think about a grade book, we need to populate the earned grades before we can find the maximum or the minimum, or calculate the average, or begin to display a frequency chart. So we, as an instructor, would know the grades of our 10 students. We're going to initialize those grades. And remember that the first is subscript 0. Grades, subscript 0. subscript 1, 2, 3, 4, 5, 6, 7, 8, subscript 9. So we have subscripts for our grades array, subscript 0 through subscript 9 for a size capacity of 10. So when we call the constructor gradebook, it will be passing grades to the gradebook with a name reference. So whatever string is passed to the gradebook constructor, it will be a string reference back to the name variable course name. And we're going to be passing a constant array template storing integers with a student size already known to be size 10. And we're going to be passing a grades array reference back to the array that was passed to this constructor. Locally then we have a course name variable, and it will be assigned the value referenced by the name variable, which is referencing a string. And grades will be initialized to grades array, which was passed to this constructor as a reference to a array template. So it will be a copy, it will be a reference to the array that was sent to it. So let's see what we have so far with the gradebook class object. So we have our grades class, gradebook class object, and we've named a grades as a gradebook class object. So grades is of type gradebook, and it is a class object. Remember that all class objects of type gradebook know and maintain their own data members, course name, and we have a grades array. So grades knows its own course name as the string CS101, Introduction to C++ Programming, close quote, and grades as a class array template knows its own grades array data. Now remember that grades is a constant, so we aren't going to be able to change the student scores, but every grade book class object knows its own grades. Grade sub 0, grade sub 1, grade sub 2, grade sub 9. So when we initialize the 10 grades, we now have grades as a grade book class object, knowing its own course name and its own grades for this particular assignment. So in driver program, we initialized our grades variable, and the grades variable is of a gradebook class object type. So it is maintaining its own course name and grades array class template. We are initializing the string course name of the gradebook by the name of grades to the string CSCI or CS101 Introduction to C++ Programming. So we now have our gradebook grades that's maintaining its own array of student grades and its own class name. Next, the driver program calls gradebook. We're declaring a new gradebook class object by the name of myGrade. And we're going to pass to the constructor course name and grades. Well, course name is right here, the string, and grades is the array class template where we've initialized 10 grades. So we'll be passing that information to gradebook, and gradebook is, my gradebook is a class object of type gradebook. So my gradebook knows its own course name and its own grades. So calling gradebook. I can now set my own course name with the name that was passed to it. I can get the course name by returning the course name, and I can operate on my gradebook class object with the member functions known from the definition of gradebook.h. Go back to the driver program. My gradebook has been constructed with the constructor call myGradebook.displayMessage. So with my gradebook, I want to call display message. Well, the display message is defined in the gradebook header file, and display message does not expect anything to be passed to it. It's not going to return anything, but processing, we're going to print welcome to this gradebook 4 and get course name. Well, get course name is going to return a constant string reference, and it's going to return course name. Well, course name was passed to this constructor, so my gradebook knows its own class name. It will return the CS101 welcome to C++ programming. I then return to the driver program, which says, with my gradebook in hand, my gradebook is a gradebook class object where we know its grade values stored in the array of grades, and we know its course name. We're going to call myGradebook.processGrades. So we're going to go to process grades, which is a member function of a gradebook.h, and my gradebook is a gradebook data type, so it knows its own member function of process grades. So my gradebook knows how to process its own grades. Calling that method, the first thing we do is call output grades. The output grades method is not going to return anything. It's not being passed anything. So we're going to output the grades are, and then we're going to use a for statement to output each student grade's value. Well, the size of this class template is student size. We're going to initialize it to 0. Student is less than grades.size. So we'll iterate. We're going to output student as a string, and then we're going to reference in our output student grades sub 0 is housing student 1's grade. But for output purposes, we really don't want our supervisors to see student 0. So we're going to add 0 plus 1 for student 1. And then we're going to get student 1's grades from the grades array. Grade student is 0. Grade sub 0 is housing the first score of 10 in our array. Grade sub 0 is housing the first student's grade. Remember the off by 1 scenario. Next student is equal to 1, is still less than 10. We'll iterate, output student as a string, and then student 1 plus 1 would be student 2, but student 2's grade value is stored in the grades array at subscript 1. And continue to iterate to output the grades from the student grades array. Back to process grades. We've output the grades from the grades array. Next, we're going to set our precision to fixed 2 places following the decimal point. The class average is, and now we want to calculate the average, so we're going to call the getAverage function. All class objects know how to execute their own data, their member functions. So we're going to get the average, and calling that member function getAverage. GetAverage is going to return a double to the calling environment. It doesn't expect anything to be passed to it. We're going to initialize total as a local variable of type int and initialize it to 0. And here we're using our for range-based for statement. So our range variable is grade as we iterate through the grades array, starting with grade sub 0, grade sub 1, and grade sub 2 to grades size. We're going to increment total by the value of the next grade in the array. So iterating through the grades array, we're keeping track of the total of the sum of the grade scores stored in the grades array. When we're done, we have a total value. So we're going to cast to a double, and we have the expression total divided by class grades.size. So our total now is the sum of all scores in the grade array, and the grades.size is 10. So total divided by 10 will give us the double to return to the calling environment, which is process grades. And we're getting the average. So our total divided by 10 will be our double fixed 2 places following the decimal point that will be output. Next, we're going to call the getMinimum to display the lowest grade. We'll call the getMinimum method. GetMinimum doesn't expect anything to be passed to it, but it returns the low grade as an integer, and it will be printed. And then we output the highest grade is, and we'll call getMaximum. And we've seen these functions before, so I'm not spending a lot of time. The getMaximum doesn't expect anything to be passed to it. It's going to return an integer. We're going to process the grades array and double check all scores, maintaining the high score as we check each one, and then we'll be returning the high grade as an integer to the calling environment and print the high score as it's returned from that method, and a new line. And then we output the bar chart. So calling the output bar chart method. Output bar chart does not expect anything to be passed to it, and it's not going to return anything. As we process, we're going to label this as our grade distribution chart, and we'll have a frequency array that's maintaining the count of the number of occurrences of scores within our range 0 to 9, 9 to 19, 20 to 29, and so on. And for every occurrence of a score within a particular range, that particular range will be incremented with an asterisk indicating the frequency of scores within that range. and a couple of new lines to contain our output. So we're ready to run. Control F5. And we have welcome to the gradebook for CS101, Introduction to C++ Programming, exclamation point. The grades are student 1 is actually grade sub 0, student 2 is grade sub 1, student 3 is grade sub 2, and student 10 is actually grade sub 9. Remember, 0 through 9 gives us the 10 elements. The average score was 84.90, fixed to 2 places following the decimal point. The lowest grade is determined to be 68, and the highest grade is determined to be 100. And then our grade distribution chart is displayed with our scores, number of scores in range 60 to 69, number of scores in 70, 79, and so on. All right, so now I was thinking, well, that's just one gradebook object. What if we instantiate another gradebook object? And another gradebook object will know its own data members, know and maintain its own data members, and it will have access to all of the member functions within the header gradebook.h definition. So I have named, we were working with the name of the gradebook object grades. I have named another gradebook object KJ grades. And I'm going to instantiate this with a constructor. And the course name, I'm going to assign the string CSCI2240, Fundamental Programming with C++. And the gradebook object named KJ grades will also know its grades array that's storing 10 integer scores for student scores received on this assignment. And it'll maintain them in a grades array with grades of 0, grades of 1, grades of 3, to grades of 9, which give me a grades.size of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements. Remember that off by 1. We're starting with 0 through 9, which is 10 elements. So in my driver program, I'm creating a new gradebook object, and actually I'm creating 2 objects in my program now. I have my gradebook.h definition, which defines all the data members and data functions that a gradebook object will know. Each gradebook object that I instantiate with a constructor will know its own data members and be able to know its own tasks defined by its member function. So in part 2, I'm testing by adding another gradebook object. Create a new gradebook object named KJ grades. So I'm going to set up my constructor call. It's a constant array template that's going to be storing integers. It's going to be a gradebook, the size of students, and students is known as a constant from the header definition. So the constant size students is set to 10. So this gradebook object will be instantiated with a gradebook size of 10. This gradebook object name is KJ grades, and I've initialized it to 10 grades, 10, 20, 30, 40, 50, 60, 70, 80, 90. Those are the grades that my students received on this assignment. And the name of this course is course name KJ, and its course name is the string CSCI Fundamentals of Programming 1 with C++. So I'm going to instantiate gradebook is the data type of my gradebook KJ. This is the next gradebook class object. And I'm going to instantiate my gradebook KJ class object with a course name KJ, and course name KJ is the string. And I'm going to send or pass the KJ grades array, which has been initialized to include these 10 scores. Subscript 1, subscript 0 through subscript 9. So instantiating, my constructor initializes a new gradebook object with its course name and its grades array. So I'm passing a name, which is a reference to a string, and I'm passing a grades array, which is a reference to an array template of type int with a student size of 10. So the name is a reference to a string, and sure enough, my gradebook is being now instantiated, my gradebook KJ with a course name KJ, which is C++ Fundamentals of Programming 1 with C++, and the KJ grades. So we're passing name as a reference to that string, and grades array will reference my KJ grades, or grades KJ. So locally, course name is going to be assigned the string referenced by name, and grades, the grades array, will be assigned the array referenced by grades array. So now my new class object my gradebook KJ has been instantiated. Next, I can call display message with this object in hand, and it's my gradebook KJ class object that I want to display the message. So display the message with my gradebook KJ, and my gradebook KJ knows that its course name is course name that was passed to it as a name string reference to the name passed, which is an instantiation CSCI2240 Fundamentals of Programming 1 with C++. And it can display I guess we're back here to display our message. With my gradebook KJ in hand, we're looking at that object. It knows its own data members and it can process its own member functions. We're going to call process grades using my gradebook KJ. So processing grades. We begin again to output the grades with our course name and grades known for this class object. Calculate the average, the minimum, and the max, and display the output bar chart. Now, what's very important here is that we've defined all the tasks of a gradebook object in the gradebook.header file. So it can maintain its own data, a string array, a string by the name and its own array template, and we're referencing them with variable names, name and grades array. It's all generic. When I set up a new and instantiate a new variable by the type of a gradebook object, it will be, I simply need to change the constructor and call each method explicitly with this gradebook name in hand. So I had to assign the grades for this gradebook, give it a new array name, give my course name a new local variable name, and maybe it's Math 0099, and give my gradebook object a new name. Everything else remains the same. Any gradebook object knows its own name and its own grades. Any gradebook object knows how to display its method, to process a display method. And any gradebook object instantiated knows how to process its own grades. Very, very slick, clean, but somewhat abstract. So we take our time in investigating the logic behind making use of object-oriented programming. Again, this is Chapter 7. This will be the end of Chapter 7. We'll be continuing with Chapter 8 as we move into new material in Chapter 8. So again, as always, return to D2L. And we're working in unit chapter number 7, where that lesson plan will document your required homework, projects, and tests, as well as due date and all details. Again, I appreciate your persistence and hope that you are enjoying Object-Oriented Programming Introduction to our C++ coding. Thank you very much.